Hello folks, this is an old question. It belongs to 2013 October-November paper 1-1 and question number is 34. It has been escaping my eyes till today. So one student of my private tuition group informed me about this question and I found it interesting. So sorry for escaping. So it says that two lamps are connected in series to a 250 volt power supply. So we have got two lamps. They are connected to a 250 volt power supply. So the supply is like this. The lamps are like this. This is one lamp and this is another lamp connected in series. This source is a 250 volt. So this is lamp 1 and this is lamp 2. So one is rated at 240 volt 60 watt. So its rating is 240 volt 60 watt and the other is rated at 10 volt 2.5 watt. Now which statement most accurately describes what happens? So for that we have to find how much power will each of them consume when connected in a series. So this power and this power is the rating. It means at this volt they consume this power, at this volt they consume this power. From these two quantities, two pairs of quantities, we can find their resistances. So what I can do is R1 is equal to V1 square by power 1. That's equal to our V1 is 240 squared, power 1 is 60 watt. So its value should be equal to 240 square by 60 equal to 960. So it is 960 ohm. Similarly, R2 is equal to V2 squared by P2. That's equal to V2 is 10 volt, 10 squared. P2 is equal to 2.5. So it will be 10 square divided 2.5. That's equal to 40 ohm. So its resistance is 40 ohm. Its resistance is 99660 ohm. Now what we now do is let us find the current here, because both of them will allow same current if in series. So let us find the current. The value of current will be equal to total EMF by total resistance R1 plus R2. So E is equal to 250 and this resistances will be equal to 960 plus 40. So this will be 1000. So 250 by 1000 is equal to 0.25 amperes. So the current flowing here is 0.25 amperes. Now we have to find the individual power consumptions. So how much power it will consume? So I will have this P1 nu is equal to I square into R1. That's equal to I square is 0.25 squared. R1 is 960. So it will give me 0.25 squared into 960 equal to 60 watt. It is 60 watt. Similarly, power 2 nu will be equal to I square into R2. That will be equal to 0.25 squared into it is 40. So that's equal to 0.25 squared into 40. So that becomes 2.5 watts. Now with these values I can see which choice is correct. So the first choice, both lamps light at less than their normal brightness. It says that they will consume less power than their normal power consumption. So let us see 60 watt, 2.5 watt, 2.5 watt. Both of them are consuming the same power though in series. So this thing is incorrect. So both lamps light normally. Normally means they are consuming the same power as before. So this is correct because 60 watt, 2.5 watt, 2.5 watt. It's a sheer and sudden coincidence. Next is only the 60 watt lamp lights. It says this only lights. No, current flows here also. This also lights and it is showing here. And says the 10 volt lamp blows. So in order that the 10 volt lamp blows, it must be consuming more power than this. But the power is again the same. So there is no chance of blowing either 10 volt lamp or the 240 volt lamp. So the correct choice is number B only.